Electrons. How do they even work? We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyperrulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. So, yes, this is me actually finishing some homework that I had started about a year or so ago. I didn't quite finish it. I got scatterbrained to all the other things. I just finished it earlier. But electrons, how do they even work? The electron, the negative. Apparently, some of the things got messed. Ben Franklin took a shot in the dark, and he's like, "It's negative." It turns out apparently electrons are positive. That shouldn't make a difference for anything, should it? We continue. It's a subatomic particle with a -1 elementary charge, electric charge. Electrons belong to the first generation of a lepton particle family and are generally thought to be elementary particles because they have no known components or substructure. The electron's mass is approximately 1 out of 1,836 out of a proton. It's pretty interesting. And they go on here, and basically this is how different orbitals, the energy levels, and everything are working. Apparently, there's some cool new photographs. Apparently, allegedly, but why do I say any of this stuff? All right, we go over to our friend Wolfram Alpha. Links on the doobly-doo. What the heck is this monstrosity that I have typed in here? Okay. This I learned from a book and also online. You can also get the books online, I'm just saying. But this was a particular. Oh, let me actually do my fancy things here. Okay. So we actually have the picture. No, that's not the correct picture that I'm looking for. Okay. No, I'm so bad at these things. It's all right. Oh, is that the measurement? No, that's okay. It's okay. Here we are. Basically, this is the equation. Hold on. I'll just bring up the dang poster. Yes, we are very professional here. Oh, even though it should be probably, oh, right there. Boom. Okay. Yes, the beauty of live internets. All right, what is this? This is something that's been on the internet for a while. Again, this is what caught my attention. That has this label as orthogonal maps of the Planck mass boundary. Shout out to Thad Roberts. Full disclosure, I am an intern at the physics monastery. We should be open and transparent as much as we can about these things. But basically, the mass of the electron is essentially it's 2 volumes of the figure 8 knot hyperbolic. Its complement. Hyperbolic figure 8 knots complement volume. It actually has a volume. It's defined. It's this crazy equation we're going to get into a second. All right. That's multiplied by the Planck mass to the 4th. According to the analysis of the hyperbolic figure 8 knot, its complement, you can essentially derive the Planck constants, just as far as at least time, space, mass, charge, temperature are concerned. And apparently that's all we really need, all the different ingredients we need to make up at least our measurements as far as we know it. But I digress. And then the other thing that's noticed is right around the time you get to about 7 decimal places, a lot of these things, it doesn't quite see. Isn't this why like GR or something, when you, depending on how you view it, it's like one of the factors goes up by like cubed or something like that, length cubed or something. I don't know. I'm just like, seems a little, not always. We also have some pretty good measurements. I'm just saying. Yeah. You want to confirm this with observation because we can. It's important. But yeah, so basically what this is the because this construction is essentially a hinged construction. Sorry, you basically have your primary action here, and then, okay, you get 1. It could be plus or minus. This particular action is hyperbolic sine of a hyperbolic sine, and then that red n, it's 5-dimensional flavors we're working with. B, that is 7. It's the break and scale symmetry of the hyperbolic figure 8 knots complement. Basically, if you're going to have a circle, you can divide into 7 equal circles. It's a pretty neat thing. And then you parentheses that, you raise it to the -1. All right, so you're going down to power. And you bracket that, and you go down another power, and this is the balance map, which that 7 decimal place thing, it's very interesting. If you play around, you end up finding out that when you take the Planck mass times it by the Planck length, you put that all over the Planck charge squared, comes out to exactly 10 to the -7. Yeah, basically 7 decimal places. That's interesting. But, okay. I don't need to bore you all with my blathering along. Hey, Whitechapel, thank you for joining. But I think things are going to get really exciting because I actually started to understand this thing. But all right, what the heck am I talking about? All right, boom. All right. Go back to our fantastical equation here. It's basically what I just showed. I just threw in the numbers because in order to calculate this, it's easy. Wolfram Alpha, it works very well. We're only trying to basically, quote unquote, hack the universe with a MacBook Pro. All right, so we got that too. This happens to be the figure 8 knot, hyperbolic figure 8 knots complement volume. It's a very beautiful thing. Go to Wolfram Alpha here. Look, figure 8 knot, hyperbolic volume. It's that crazy thing there. I mean, you can put in the numbers if you want, but that should basically get you something because it's a math thing. We can compute for however long we want. Typically about 14 decimal places, so pretty good. Okay. And then we multiply by, this is the Planck mass. Now, this is something that, again, numbers and equations are available. I need to do a lot more homework. But essentially, this is included in my video, that how I stumbled upon theory of everything, best theory of everything yet. Shout out to Kurt Jai Mungle from the Theories of Everything YouTube channel. And yeah, you can geometrically calculate that out to however many digits you want. This is 14 here. And that's basically 2.17 yada, yada, yada times 10. Typically, if it's in kilograms, into the -8 kilogram, it's really small. It's about like the mass of a mosquito egg, approximately. Big on kind of like the quantum level, because it's something we can actually kind of conceptualize. Okay, and you raise that to the 4th. All right, so you basically got 4 Planck masses. You multiply that by 2 hyperbolic figure 8 knots, or if you want, 4 Geeskiing manifolds. Okay, that just fully clicked right now. That's why these things are good. I see why Professor Wolfram does these things. As you're explaining it, yeah, I know that, but it's like, oh, interesting. That's to the 4th, so it's orthogonally going to line up there. We multiply it. This is where I got confused. I was missing a parenthesis somewhere, and because it just kept not looking right. Like it wasn't set up like this. So it's like, all right, you got 1. And remember, we had that -1 in the thing there. Okay, -1. And then you go out of parenthesis, and then we also had this. This is what we're multiplying by the negative. This is actually very pretty when I look at it. 5 dimensions, break and scale symmetry, and then times 10. Wait a second. I want to make sure. Okay, yeah, -7, but how it's loaded up there, it's multiplying. Okay. All I know is the math works out. But, and again, it is actually very, okay, because it's over the 1. Okay, there we go. Oh, okay, that's why I was getting like ridiculous numbers or just really close. But, okay. So we get this number here. What is this? What is this number here? Oh. It's 9.10938,370 times 10 to the -31. This is from physics.nist.gov. Numerical value of the fundamental physical constants for the electron mass. Numerical value 9.109383715 times 10 to the negative 3 with the error bars. Okay, those last two digits. Okay, up and down. That's what it said. Go back to our thingy here. 9.1038370. 38370. Here, let's put it to kilograms. Oh, that appears to equal the mass of the electron. Utilizing the HF8 model presented in Thad's book, source code 7 and 44. Some of it in the perfect universe. But apparently, this is the biggest thing that I took away from string theory, and Edwin once said, string theory showed that mathematics can model reality. And that's really cool. But learned a lot about math just doing this. All I know is, hey, it's a crazy world out there, but there is truth out there. Otherwise, why would I have it tattooed on my arm? In Latin, that is. But peace out, everybody. Thank you all for watching. Be safe, and hey, gotta have a little bit of fun out there. Otherwise, you might go crazy like me. But
we won't be going hungry if we do this, that's for sure.
Dude, my hat has made over $10 tonight.
I guess I'm gonna have to wear a cowboy hat on here with you next time too.
Howdy.
I'm not a doctor, but UV radiation can be dangerous. Peace out, everybody.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.